Okay, well, hello everyone. My name is Jason Walls from CloudShark, and I am here with our technical specialist, Tom Peterson, and we are going to be showing you how to troubleshoot AWS environments using packet captures. And what this really means is, so AWS systems recently added a concept called VPC traffic mirroring, which allows you to create a mirror port that you can sniff traffic on. We're going to show you how that works and how to set it up and why it's so important, and also how CloudShark is kind of a natural fit for this sort of environment and how it can help you to use packet captures to troubleshoot your security in the cloud or network applications or network performance. So what is AWS VPC traffic mirroring? What it really does is allow you to create a virtual network interface that mirrors the traffic of another AWS network resource. So if you are hosting some type of server on AWS, but you want to be able to analyze the traffic that's going to and from one of the network interfaces on that resource, you can create a virtual interface on another resource that will mirror the traffic to a system that's built for doing packet captures on that traffic. So this acts as kind of a perfect capture point, just like a network tap. So one of the things that we often say is that it's not necessarily good to do packet captures on the system that you're trying to analyze for a number of reasons. And so this works like an actual network tap that you would set up in your own network. This diagram here, Tom's going to keep coming back to it to kind of explain how things work as he goes through it. Don't worry about memorizing those terms, but this is the basic layout of how it works. You have your main network resource, and then you've set up a mirror target that has VPC mirror session traffic go to it. And meanwhile, and then when you're done doing a packet capture with TCP dump or some other application, you can use CloudShark's API upload to send it to a CS enterprise instance, and then your whole team can look at that. So why is this so important? So this has actually been a topic for quite a while, and I know that different people have tried to solve this problem in different ways, but it's kind of been a holy grail of cloud deployments to be able to troubleshoot systems that you've deployed in the cloud, because you do need to still get to the packets in order to get down to the bottom of a lot of different security and performance problems. And it does help your team resolve things faster and be a little bit more detailed, find out exactly what the real problem is and avoid false positives and that kind of a thing. But running captures directly on the EC2 instance that you're looking at isn't necessarily good practice. For starters is the tap problem that I mentioned before. If you do a local capture, you're not necessarily going to get the most accurate data because different things are happening at that capture point. You are at risk of overusing resources. So the EC2 instance that you've set up to actually do the things that you want it to do is built for doing those things. And so if you're all of a sudden generating huge packet captures on that instance, you might have to end up expanding the disk space by a lot, or it might end up using memory or processing that the system was not built for. In addition, it is kind of dangerous to be running commands on a production machine like that. You don't necessarily want people to be SSHing in and running commands that are not part of what that resource is built to do. And that includes different people having different permissions to those systems. So you might have people who are analysts that aren't necessarily the IT staff or the network staff that is supposed to be looking and logging in to manage that EC2 instance. So being able to set up another system that is mirroring the traffic to that system and having it being dedicated for the analysis of traffic from the other system is really the way to go. Now, CS Enterprise is uniquely suited to this situation. So even when you're able to set up these instances that are built to source the network traffic from another instance, and turn those things into packet captures, what do you do with those captures? Without in order to use some other packet capture analyzing systems, you probably have to retrieve that file in some manner, take it out of the AWS network environment, which isn't a good idea. So CS Enterprise is really suited towards simplifying, getting the data and putting it in a place that it can be analyzed. And we were talking before about having different permissions for different systems. You're probably going to have many different teams involved in troubleshooting these situations, and they don't necessarily have access to the same resources or permission to access those resources. And they really should only be looking at the things that they need to be looking at, not just from a security perspective, but also from an efficiency perspective. And like I was saying, so CS Enterprise can install directly in your AWS environment, so you don't have to sort of waste bandwidth and risk security or add any additional complexity to trying to get those captures out of the AWS environment in order to do that analysis. So now I'm going to switch things over to Tom, who is going to go through setting up a VPC traffic mirror on some different instances that we have, show you how it works, how to capture traffic on that interface, and how to send it to CloudShark.
All right, hi everybody, this is Tom from CloudShark. So like Jason mentioned, what I'm going to show you today is how to set up one of these traffic mirroring sessions in AWS. Then we'll take a look at how to capture this traffic using TCP dump on a separate instance that we're going to use to capture the traffic being mirrored. And then finally how to upload that capture to CloudShark to upload, analyze, and collaborate on this PCAP, all while staying within the AWS environment. So here up on my screen right now, I've got a simple topology showing what we've kind of set up within AWS. So here on the left side, we've got an EC2 resource that we're going to use to send traffic. That has one network interface that we've got connected to the internet. Also within AWS, I have another EC2 instance that we're going to use as a mirror target. So this also has a connection to the internet, which we're going to use to connect to the interface. And that's also what we're going to use to upload our capture file to CS Enterprise running within AWS. That has a second network interface that we have configured, and that's going to be used as the target of a VPC mirroring session. So we can use that interface to capture, using TCP dump, to capture this traffic that's being sent from our EC2 resource up to the internet. So to take a look at what that looks like, I can go to the AWS Management Console. And here we can just see those EC2 instances. So here we've got 3 running instances. So we've got our EC2 instance that we're going to use to generate some traffic to capture. We've got an instance running CS Enterprise that we can use to upload this capture to, keeping that capture within the AWS environment. And we can use that to look at the uploaded capture and analyze that and collaborate with other members on our team. And I've also got our EC2 mirror target interface. If we take a look at what this looks like, you can see under the details here, we do have 2 network interfaces. So we've got ETH0, which is our connection to the internet, and ETH1, which is going to be our mirror target. So we've got ETH0 here as our connection, and then ETH1, which we're going to use to capture this traffic being mirrored. So to take a look at how to set this up, a mirroring session, we'll take a look at how to set up this connection right here within AWS. So going back to our console here, we're going to do this under the VPC section. So that's under networking and content delivery. So this is where you set up your private virtual network. And in here we can see we've got a VPC defined. All the way at the bottom is where we can set up this traffic mirroring. So to start, let's start by configuring our mirror target. So that's going to configure an interface that we can use to send traffic being mirrored. So if we take a look, I've already got one set up, but if we take a look at what it looks like to create one of these, this one's really simple actually. You can give it a name and a description. And then for the target, you can select either a network interface, or if you have a more complex environment, you can use a network load balancer to send this traffic to one kind of logical place and then send the traffic to multiple places to be analyzed after that. We'll select a network interface. And here we're going to select as an interface our EC2, on our EC2 mirror target interface. We've got a target interface. This is that ETH1 connection. So that's this interface right here in our topology. So once we have that configured, the next thing that you're going to want to configure, this is required for a mirror session, is a mirror filter. So what this is this is a filter that can be used to select which traffic on this mirror source interface, what traffic we actually want to send over a mirror session. So if we take a look at that, again, we can give this a name and a description, and then we can specify input and inbound and outbound rules. So to take a look at one of these, this works similar to something like a firewall, where you can have a list of rules, and the first one that matches the traffic is what's going to be, what action is going to be taken. So for action, you have accept and reject. So we can select which traffic we want to mirror, or we can reject specific traffic, maybe something like, our SSH connection. And you can select, what protocol you want to accept or reject. So something like TCP, UDP. We can specify source port and destination port ranges, and actually also the IP addresses that we want to mirror. So this can be really useful for, filtering down this traffic before capturing and analyzing it. If you have a specific application that you're troubleshooting, or if there's some traffic that you don't need to capture, you can create a mirroring filter to achieve that. So here, for the one that we have, that I've defined, we're simply accepting all traffic. So we're going to see everything, both inbound and outbound. So we can take a look at all the traffic. And once you have those two things defined, now we can finally configure this VPC mirroring session. So we can specify which interface we want as our source, where we want to mirror this traffic to, and we can do that by setting up a traffic mirror session. So to create one of these, again, name and description. Next, we can select a mirror source. So this is the resource that we want to monitor, or the resource that we want to mirror the traffic from. So for our example here, we want to look at our EC2 instances internet interface. And for the mirror target, we've only got one defined here. This is the ETH1 interface on that EC2 mirror target instance. So here we've got our mirror source as this EC2 resources connection to the internet, and our mirror destination is that second interface on our mirroring target. There are some additional settings here. So you can define a session number. There's also a VNI. This is an optional thing you can specify. This is a VXLAN network identifier, and we'll dive deeper into that and show you what that means and what that is. If you don't specify one, a random VNI gets chosen, but you can specify this up front if you know what you want that to be set to. You can also optionally set a packet length, so you can chop packets to a specific length, and you select which filter you want to use, so which traffic is going to eventually get mirrored to our mirrored target. So we've already got all of that set up within AWS. So right now we're actually already mirroring all the traffic from this mirror source interface, and we're sending that to our mirror target interface. So I'm going to switch over to a console here. So here we're SSH'd into both of those instances, our EC2 instance and our EC2 mirror target. So to take a look at what these look like kind of under the hood, we can use ifconfig. And here's our EC2 instance. So we have our ETH0 connection. So this is our connection to the internet. And going back to the diagram, that's our mirror source right here. And switching over to our mirror target, we're in this machine now, EC2 mirror target. Let's take a look at that. We can see both of those interfaces. So we've got ETH0, that's what we're using to connect over SSH into this interface. It's also what we're going to use to upload this capture to CloudShark, our other instance running in AWS. And we've got ETH1, so this is our mirror destination here. So here, just looking at this topology again, we've got ETH0 as our internet connection and ETH1 as our mirror target. So on our mirror target, let's start a capture here on ETH1 so we can take a look at some of this traffic that's being mirrored. So for this, we'll use TCP dump, and we'll specify our interface as ETH1, and we'll save this capture locally for now into a file, and we'll start this capture. So now on our EC2 instance, we'll go back to that. We're just going to send a ping so that we can have some traffic that we're going to look for in the resulting capture. So let that ping for a little bit. And now we'll go back to our EC2 mirror target and we'll stop this capture. And using the CloudShark API, we'll upload this to CloudShark. So this is a script that we've written to push the capture into CloudShark over the API. So this uses an API key. And if we push that capture, that's going to upload the file to our EC2 CloudShark instance. And it's going to give us a URL that we can use to open this capture within CloudShark and analyze it. So if we copy this, we'll go back to the web, and here we can connect to our instance running. This is still running within AWS, so the capture hasn't left AWS. You don't have to worry about going and pulling that down or managing that within AWS. It's right in our CloudShark instance. So here we have a capture, and we can start to look at it to see what traffic has been mirrored. So here we can see some SSH traffic. This is traffic that we're sending. We're connected to our EC2 resource over the internet. So that's that SSH traffic. And if we look for those pings that we sent, here we can see that those echo requests and echo replies that we sent on our EC2 instance. And we can also actually see some ICMP destination unreachable messages. As far as these addresses goes, we've got 217, so 10.0.0.217. That's our EC2 instance. And 10.0.0.51, that's the IPv4 address of our mirror target. So if we look here, we've got 10.0.0.51 as our mirror target. And going back to the EC2 instance, let's put that top, 10.0.0.217. So here we can see the echo request being sent up to Google from our EC2 instance. The echo reply is coming back down. To take a deeper look into this traffic, we can look at the traffic decode. So here we can see, go back to the echo request, we can see our echo request message. That's an IPv4 packet being sent from our instance within AWS to Google. So we can see we've got the GeoIP information showing us that destination address is owned by Google. But if we keep looking, we've got our Ethernet layer, and then we've got something called a virtual extensible local area network header. So this is that VXLAN encapsulation that we looked at a little bit earlier. So this packet is actually being sent with a VXLAN header. This works very similar to a regular VLAN, but that traffic actually gets sent over UDP on destination port 4789. We can see that this packet is actually being sent from our mirror source, the IP address of our mirroring source, to the IP address of our mirror destination. So to take a look at that encapsulation, we've got a little diagram here. Make that a little smaller. So we can actually see that ICMP ping is being sent over the VPC mirror session and is being encapsulated with this VXLAN header and being sent over UDP to our mirror destination. So that's all being encapsulated there. And we haven't set up anything special on our mirror destination. So that mirror destination, it's not actually listening on that UDP port. So that's why we're seeing these destination unreachables coming from our mirror target. These are saying, port unreachable, and the traffic in question is that mirrored traffic being sent over UDP. So if you were just to capture like this, it could get very confusing. We're seeing traffic from our mirror destination, not something you want to see from a network tap. So let's take a look at how we can configure our mirroring target to decapsulate that traffic so we can get a look at what's actually being sent from our mirror source. So to do that, we'll go back to the console and we'll take a look at this mirror target, and we'll set up a VXLAN interface. So to do this, we're going to use the IP Linux commands. This first one here, we're going to create a new interface. I'm going to name it Capture 0, and this is going to be a VXLAN interface. So here we've got that VNI, VXLAN ID number. So here we've got that specified. If we go back to where we set up our traffic mirror session, this was that optional field that you don't have to specify. If you don't, one will be chosen at random, but you can specify that ahead of time. And we can actually look at the details of this mirroring session and find the VNI right there. So we can use that as part of our IP command to create a VXLAN interface that will be associated with that ID. Next, we're going to specify our local IP address. So that's the IP address of ETH1 on our mirror target. So that's this interface here, the IP address of ETH1, that interface there. And the remote side is going to be the IP address of the network interface that we're mirroring. So that is on the EC2 instance, and that's the IPv4 address right here, the one that's connected to the internet and the one that we're actually going to be mirroring. And finally, we're going to associate that with our ETH1 interface. So that's our mirror target interface. And we're going to specify that VXLAN traffic is coming over UDP on port 4789. That's the default VXLAN UDP port. So let's copy this, and we'll paste this to create that interface. And we'll bring that interface up using IP link set capture 0 up. So we'll copy that and paste this. And finally, if we take a look, let me copy this command first. If we take a look at that interface from here, we can actually see it also does have IPv6 enabled. So if we leave that enabled, capture 0, run that again. This is that capture 0 interface. We don't have an IPv4 address. We haven't specified one, but we can see the IPv6 automatically is enabled. So we're actually going to disable that just so we don't see any traffic from our mirroring destination. So nothing that's going to interfere with that capture or show up in the resulting packet capture. So now that we have that set up, we can take a look at that interface now. So now we don't have an IPv4 or IPv6 address. And now again, we can start a packet capture with TCP dump. And here we're going to specify the interface now as our new VXLAN interface, capture 0. And again, we'll save this capture off and let this run for now on our mirror target. And now that we've started a capture, let's go back to our EC2 instance. We can actually run a little speed test here. So this runs, we'll run an upload test. And you might run this if you were, trying to troubleshoot the performance of a specific EC2 instance, verify the speed that you're getting, or to make sure that there's not an issue, with the network on this instance. So running that, we can see it's running the speed test with speedtest.net. We can see it retrieves a server. Looks like it found one in Virginia. And we can see it's testing the upload speed, and our upload speed is 671 megabits per second. So now let's go back to our EC2 mirror target. We can stop this capture. And again, we can upload this using the CloudShark API. And this script is available up online. Well, we actually posted it in the article that we wrote about VPC traffic mirroring, so you can find it there. And again, we'll upload this capture to our CloudShark instance running within AWS. So we're not incurring any bandwidth, downloading this capture from AWS. It's all staying right within that environment. And again, we've got a URL to the capture that we uploaded. So we can copy this and go back to our web browser. And we can take a look at this in CloudShark. And here we can see, again, we've got that SSH traffic to that instance. This is us connecting to it to run the speed test. But what you'll see now is this traffic, we've got SSH, TCP, and V4. We're not seeing that VXLAN encapsulation. So now we're actually capturing just this traffic here. Our Linux instance is doing all the work of decapsulating, stripping off this VXLAN header and the UDP and IP layers, and we're just looking at the traffic as it was sent from our mirroring source. So now we can actually just see the raw traffic being sent on this interface here. So looking at this, we can see in our bandwidth graph, we've got not a whole lot of traffic, and then all of a sudden a huge spike, likely our speed test. We can take a look at the protocol conversations to try to find where this traffic starts. So we can open this, and here we can see all the IP conversations in that capture. We can sort that by the total number of data sent, and our speed test is likely the one with the most data here, 138 megabytes. So clicking on this is going to generate a filter expression for us for just that traffic in that conversation. So here we can see the source and destination IP addresses. If we take a look at the traffic, we can see it looks like our EC2 instance is selecting a server to run the speed test with. We can actually see that in the output of the speed test as well. So here we can see it's retrieving a configuration and a server list, selecting the best server based on a ping. If we look at this traffic again, we can see that looks like this HTTP traffic here. And going down, we can see this looks like the start of our speed test here. So we've got a three-way handshake, and we can start to see a lot of data being sent between these IP addresses. So that looks like our speed test there. And using the annotations feature within CloudShark, we can actually make a note and annotate that, saying that here is the speed test, and maybe it looks like there are no issues. And we can save that annotation, and now it's going to appear right on that packet. We can hover over to get some more information about that. If we had to find this annotation again, these are also listed under more info in the capture. So here we can see a list of all the individual packet annotations, any user comments that we make on the whole capture file, maybe saying something like where it was taken. And from here, we can also share this capture. So here you can see this capture is owned by me. I'm the one that did the upload. But if I'm collaborating with someone, maybe on our applications team, and had to share this capture file to show them a particular issue, or to show them that there is no issue maybe, I can assign this to our group, and I'll save those changes. And since we've got a filter expression right here that's already narrowing down kind of where our speed test is, that filter expression is actually also a part of this URL up top here. You can kind of see it URL encoded up in the top. But I could copy this, and I'll send this over to Jason so that he could collaborate on this analysis and see, where I am in the analysis, any notes that I've made on this capture.
Sweet. All right, I'm going to do that right now. So if we go to bring my screen back up here, I click on the link that Tom gave me. It's going to open up this browser. So you can see the link at the top is our AWS instance that we're running. So I'm going to log in as Jason. And now I have access to the exact same captcha that Tom just sent me. If I go to so I just was sorting these columns. So you're actually looking at the newest view of CloudShark. We recently released CloudShark 3.6, which incorporates our trace frame technology to make this view much more snappy and responsive and load a lot more packets at once than we could before. And I can also sort on the columns here. So I just sorted on which ones have comments. And I can see the annotation that Tom added here. I can go back and put these in order. And here it is here. And so, yeah, the URL contains all the information I need. So if I were to send this to anyone else who's looking at it, they're going to see exactly what I see. If I go to my capture list view, you can see all the captures that have been shared with me that I have permission to view. I might want to tag some of these. I might want to select several of them and do a deep search. If there's like a particular IP address that I'm looking for, or a particular security indicator of compromise, I can search using a filter doing this, and it's going to reveal which captures hold those things. I can use any of the analysis tools that I have access to, and all of these are going to become a URL. So if I look at a ladder diagram of what's going on, this is one of our fancier protocol conversation views. So you can see a whole bunch of different stuff happening in this. But this is also a URL that I could share or put into a report or trouble ticket somewhere. And then also our profiles. So if I had write access to this, or if Tom wanted to set it up ahead of time, if I'm kind of a newbie, or there's a specific workflow that I'm supposed to be going and looking for this particular kind of problem, he might set up the columns that he wants me to look at, or I might set up the columns that I want to look at and apply these to the capture so other people can see them. Or if there was any encrypted traffic that we wanted to decrypt that we had the keys for, we could use that. Or any of the presets that we have in CloudShark. And as a quick spoiler alert, this is this profile view that we just kind of moved around in CloudShark 3.6 to make it more convenient is setting the stage for some more powerful profile management in the future that will make that collaboration easier. So you could come up with a set of profiles that you want to share with specific kinds of analysts so that they'll apply those things to a given capture when they look at it. All right. So what did we learn today? We showed you exactly what a VPC traffic mirroring interface enables in order to do cloud packet capture, how to set it up and use TCP dump and scripts to upload to using our CloudShark API to upload to a CS Enterprise instance running in AWS, and how CS Enterprise is kind of ideal for this scenario, specifically because it is native. It runs natively in AWS, so you never have to take those captures out of your environment, and it's very conducive to having a remote location where everybody's collaborating on the same problems. A couple of resources before we get into questions. If you are looking to start a CS Enterprise demo and want to see how this works in AWS, you can make a request there. We have instructions on how to install on AWS on our support site. The upload script that Tom was using is in our more detailed article about VPC traffic mirroring. We have some links to the GitHub repository where that exists, so you can easily use that. And then Amazon's link to their in-depth detailed look at how VPC traffic mirroring works can be found there.